All right, this is 5.3, example one. Right away, I'm going to start with the tan function. It is in radians, so it's a little bit different than what you saw. Definitely a good idea to pause that and reproduce it on your graph. There's a bit of a different scale, but that's part of the learning process, is to be able to take that information. Please remember that if you're stuck, put y equals tan x in your calculator. Make sure you're in radian mode for this. And you can actually type in pi over 2 or pi. I mean, if you put pi over 2, your calculator is going to give you an error there. Now, some of this we already talked about in the instructional, but I think it's really important that this graph, it even has it highlighted, that if we picture those asymptotes as repeated points, then they are going to repeat every 180 degrees in degree form. But in radians, we are going to say that the period of a tan function is actually just pi. And that's going to be something that's very important, that if we transform a tan function, then it's pi divided by b, not 2 pi divided by b. And we'll see that in 5.4 in a few days here. The other important consideration is that there is no minimum and maximum. So it doesn't make sense to talk about the amplitude of a tan function. Tan theta is the largest number you can think of and the most negative number you can think of at particular angles. All right, a couple important other things is our asymptotes. Where are our asymptotes located? And I actually like doing the domain first to talk about this. And the domain is that x cannot be equal to pi over 2 plus n pi, where n is an integer. Now, what I would really recommend you do is go back and take a look at the instructional video and make sure you understand why that is. In degree mode, that's 90 degrees plus 180 n. Right, and that's going to talk a little bit about that period of the function. That's how long it takes to repeat. So it's also how long it takes the asymptotes to repeat. Now, really importantly, those are the, and I put x here, which is just an oversight. That really should say theta. I'm going to fix that just because it is nice to be consistent with that. So the angle cannot be pi over 2, but it can be any other real angle, or, the multiples of pi over 2 plus n pi as well. It cannot be. The range, a little bit easier. Because there are no maxes and mins, or if you look at the graph, it extends forever in the positive and negative direction of the y-axis. So y is just an element of the real. And I do want to make that connection that because it does not have a minimum or a maximum, we do not describe the amplitude of tan functions because they're really, infinite, which is not a valid number. Okay, some other important kind of general characteristics about tan is that it is not continuous. Right, it is broken by those asymptotes. That doesn't have a big implication in 30-1, but when we get to Math 31, calculus, the fact that it's not continuous in some locations means that it's not differentiable in those locations. All right, the asymptotes. We have vertical asymptotes, and I'm just going to put in a bracket behind that vertical. There are no horizontal asymptotes, but the vertical asymptotes occur when theta is, and I'll write out this list, it's negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and that pattern continues indefinitely in both directions. And the way that we can summarize that is our vertical asymptotes occur when theta is equal to pi over 2 plus n pi, where n is any integer. And I'm hoping you can recognize the connection between our domain and our vertical asymptotes. Anywhere there's a vertical asymptote, the function can't have that angle. So there's a very, very kind of implicit or linked relationship between those two things. All right, that's the 5.3, graph the tangent function. I'm going to be honest with you guys, we don't do the tangent function as much as sine and cos. We are going to do an interesting application of the tangent function, but for the most part, this course does focus on the sine and the cosine graphs.